Welcome to MBA Module 2. We're still here together with Hasain, and we're still covering Windows security and forensics. This module is all about memory attacks and forensics.
And forensics, or memory analysis.
Memory analysis, right? So we will talk about what memory contains.
Yeah. Or maybe, rather said, we will show a lot of demos about what memory contains.
Okay, what if it's encrypted?
Well, still, the encryption keys or decryption keys still needs to be somewhere, and that's in memory as well. Nowadays, they might be in pieces of hardware we have in our computers, but that's a different discussion. So,
okay.
We will get to there.
We will take in level 300 session.
Yeah.
Then we will talk about the importance of the artifacts found in the memory. Then probably this is also telling us why hackers are attacking memories, right? Because we get all the answers already.
Yeah. The way we are interested in analyzing memory and the things we will find in memory, that's basically the same things attackers are going for in memory as well.
Okay. So
there is a typical, whenever there is an incident, there is a typical life cycle for what's happening after that. So how does that look like for you?
Okay. So the security incident response life cycle, for this to be happening, the event has to start, right?
Yeah.
Someone has to get hacked, or some sort of event has to happen. Then for us to be able to get involved, the event has to be detected. This could be an app where the dev operation team has to be engaged. This could be a server or a network or A to Z anything where the security team has to get engaged.
Yeah.
And after all, the event will be confirmed where we can go and do a damage analysis. It didn't come out, but this is determined the damage analysis. And this is part of incident assessment.
Yeah.
So this will make us as incident responders to be able to tell what happened from A to Z. And a good team, an educated team, a knowledgeable team will make this process much faster.
Yeah.
Depends on the attack, network size, and hopefully we are going to be able to demonstrate what and how these incidents happen, what can be stopped. Okay.
Yeah. How much information we could maybe get hold of when looking at active memory and systems.
Let me ask you a question then, Hasain. What does really a memory contains?
Well, everything that is needed to operate your operating systems and run your applications must reside more or less in memory. We have something that needs to be stored very short in memory, and then we just need it for a small period of time, and we have some other things that must reside in memory for longer periods of time. We should
Before we go there, should we quickly explain what a memory is? I know it's a level 2 to 300, but just to make it clear, memory is the hardware which is used to store information for everything, right?
Yeah.
And it's usually a piece of hardware which is quite fast, which contains a lot of information. Again, very quickly, there's two types of memory types. One is the validate memory, and the second one is the non-validate memory. The difference is the validate memory requires power to get store information,
to maintain information,
where the non will work without power as well.
Now this is getting very interesting. Specifically now when speaking about clouds, because these two definitions are going more or less into each other's. We see that we're using flash-based storage, which is basically memory. So sometimes because of the need of having super speed kind of access, we need to have very short access times and so on. So we use more of the volatile type of memory for storing pieces of information for longer periods of time, simply because it's much faster. So it's a little bit going forth and back and touching each other's. So these definitions are the classic definitions, and we should rather see them as this is what it used to be. Okay. And we still have the storage, the persistent storage option. So we're still speaking maybe less about memory types, more about how long period of time this will be stored for us in the system.
Just to make it clear to our low-level attendees, think about a phone with a hard drive.
Yeah.
It will be noisy.
Yeah.
We already complain about battery levels. It will chew up the battery, and it will be much easier broken as well, besides the speeds. Okay, back to my original question. What can be found in a memory? I know we have the keys, the secrets, the credentials, and we can have much more important and interesting pieces of information which can be found there. And for that, I know we prepared a really great demo. But just to make it clear, how is the order of validity? First of all, it's stored in a memory. Maybe then in the cache of the network, in the hard drive, or removable media. I mean,
if we're speaking about, it might be a file that was just created by a text editor or something like that, and it's basically running in memory altogether. Then once you start saving it, you will transfer that to some kind of a storage device. It might be a shared folder or something like that. It will be in the cache memory of the server, the client, during the transport. And then finally, it will end up on a disk drive somewhere, on a storage cabinet or something like that. So a typical maybe life cycle of something, from just being as an object in memory, allocated space in memory, till you find it as an object in a file system.
Okay, Hasain, I know you don't like PowerPoints, okay? I know you like more to show off your knowledge without the slide deck, which I believe we need to have them, especially in an academic course like that. Okay, let's start with our first demo. Mimikatz, I think most of you know what Mimikatz are. So let's imagine we have an attack, which can be done online and offline. Do you have something in your kitchen to serve us?
Sure. So if we switch, just switch quickly to my machine, I will just jump into one of my virtual machines over here. Now this is obviously a Windows virtual machine running on my hypervisor. I'm logged in as a local admin on this machine. There are a couple of processes running on this one. These processes might contain interesting information and might not.
How can we find out?
Well, we should wait and see. I mean, we will start looking at analyzing the memory of these processes and see where we can find interesting details. Now, some of these are more important than others. I do have a command prompt running over there. There is a cmd.exe, although I'm not seeing any command prompt window
front task
running there.
It's at the back end,
so
right?
Something is running in the back end, obviously in here. There is this Mongoose small tiny web server running. I do have an Nginx. Obviously, this machine is running Metasploit framework on top of Windows. So there is a web server. So you can, by observing the different processes already in the machine, you can see this information. And we're doing this now within the host itself. We're just observing what's going on. Now, this is not the complete truth, because there might be some processes that are hidden for us. So we'll not see them with these classic tools like the task manager or similar, simply because somebody has been tweaking with the connections between processes. They will not be printed out this way.
It's what is behind the scenes.
Yeah,
right?
Yeah, that's right. So one very important process that exists in our Windows machines is the LSA process. LSA stands for Local Security Authority. So this is the Local Security Authority service or subsystem in our Windows, lsass.exe. This guy keeps track of all interesting secrets in the system. So everything an attacker would love to control will be kept by this guy in our systems. In terms of passwords, cached passwords could be clear text passwords, encrypted passwords, what we call hashes, and so on. There will be tickets for our Kerberos-based authentication, and keys involved in encryption, decryption operations might very well exist in this process as well, or in this process memory, or other set. So this is a very, very interesting process to start looking at. Once an attacker gets hold of a Windows machine and gain admin rights in that Windows machine, the first process they will start looking at is the LSA process. That's the absolutely first point of interest they will start working with. And we do either perform live analysis of the memory within the host itself, or we can as well perform offline analysis of this. So simply by creating a memory dump of that process, if we are an admin in a Windows machine, we can always create a memory dump of any process of choice, including the LSASS process, simply because an admin can at any time elevate themselves with debug privileges, and debug privileges will give you back the ability to control system-owned or system-maintained processes. So if we just look at how easy it is to do that dump, just look back on my machine again, just by right-clicking the process and telling the system, I'm running Task Manager, just create a dump file for me, please. And it is as easy as just the right-click.
Right-click.
Yeah, you will get a mini-dump file for that process. Now, an attacker would carry that mini-dump file back to their own systems where they operate their tools, and then we'll perform a memory analysis offline. The only thing I will see on my machine is that somebody created a dump file. I will see this artifact in the file system, that somebody actually made a dump of that memory of the process.
Can you quickly show us what they can do, please?
Yeah, let us just do a live memory analysis. I will do using a command prompt and run that as an admin.
Of course.
Yeah. And go to Mimikatz folder. We're using the Mimikatz tool. The Mimikatz tool has been around for a while. The guy behind this tool is definitely a white hat. He works for a big bank in France. He's actually started this project to learn C++. And I think he's been doing quite good so far. So Mimikatz exe, we run it, and then we would like to get our privilege level set properly. So privileges, and then do the debug. Let me just maximize this window so we get it all. So now we set our privilege level to be able to debug processes. That's including looking at memory allocated by those processes. And then from there, we go ahead and use these built-in, there are a couple of built-in modules in Mimikatz. One of the most interesting models is the secure LSA. Yeah, this one will look into the local security authority process and start enumerating credentials, enumerating secrets within that process. So we just run the secure LSA, and if you just want to try out what does the secure LSA do, just do it with a double colons, and it will tell you, hey, you can use any of these subcommands for the secure LSA, like logon passwords dumps, or live credentials, live SSP, terminal services, Kerberos tickets, wdigest, and so forth. And we can as well, this is how the attackers are doing, we can focus on working with a mini-dump instead of working with the live memory on the system. So we can give it a mini-dump file to work with and show us the capability of the system. So let's repeat that and do the logon passwords. And this will basically show us all different type of cached or live credentials available in the system. Let me just scroll back a little bit to the top. There we go. So it will shows this as in terms of different sessions, different processes, or different services running on the machine with different credentials. We'll see the machine name, which is CLI. The $sign indicates this is the machine account itself. It indicates it's member of a domain called SEC demo. And then we will have credential information shown later on. In this case, we do have the anti-hash for that computer account, the CLI $1.
Quickly unhash it.
Yeah, and then we could eventually also have clear text passwords. And in this case, this is actually the clear text password of the computer account in Active Directory. It looks like rubbish, but it is not.
Yes.
This is a randomized 128 character long password. So this is the clear text password of that computer account in Active Directory as it appears and as it's stored. And that's the hash value of it. So these two guys are representing the same thing in this case. And then we get all the other login sessions. I see that we are running, there is an administrator which is running locally on this. This is a local administrator account on this guy, CLI1. And the same story goes there. We do have the hashes. We do have eventually other clear text passwords if they would be stored in the system. The list we see here, these are so-called credential providers. These are providers used by different system components to provide authentication, single sign-on based authentication to other parts in our environment, like the Kerberos, the WDigest for web access, and the MSV for everything that is Windows-based, file access, and so forth. So let's see if we get something. This is computer accounts, services, everything is fully visible in there. Now we don't see any other guys logged in here except for local admin. This is the one I'm logged in with. It's a local admin guy. So if we have a situation where we have another user logging into the system, let's say you're running as a local admin, you're just a regular guy in the domain, you're not a domain admin, just a regular user in the domain, and all of a sudden a help desk guy or a server admin or anybody with more elevated privileges logs into your local machine. So let's just simulate that by simply logging in with the domain admin on our target machine. Now, it's not recommended to do that in production. Never use your domain admin to log in on client machines. You should keep good restrictions.
And I think this is a good proof why they should not do it.
Yeah, that's right. So,
okay, let's show it.
And then I do the administrator, and then type in the password for that guy. So I do have an administrator session over here. This is run with, if I do who am I, I will do, see, clearly this is the domain admin logged in into this session. And just minimize that one. Go back to Mimikatz and repeat the secure logon, secure LSA logon passwords. And then scroll.
And you got an extra user now.
Yeah, scroll a little bit to the top again. And there we go. And we do have another interactive session, which this time it's logged on with the administrator in the domain. The logon server is SRV1. This is our domain controller. And this is the anti-hash value for that account. So this is the encrypted version of that password. We don't have the password in clear text anywhere. There might be some occasions where you will actually get the password in clear text, depending on whether the Kerberos provider has been able to grab the tickets or not. It might keep the passwords in clear text for some time or so on. But this is already enough information to be able to start working on getting that level of access the domain admin is.
In the previous session, I showcased how, together with Milad, I showed how which tool can be used to dehash that. So we did cover that.
Yeah.
For the ones that didn't watch it, please refer to the previous Microsoft Virtual Academic courses that we have recorded with Milad Aslaner.
Yeah.
It's the same?
Yeah. So let me just, I will keep that. This is the hash value of the domain admin. I will just keep it in Notepad. And then we'll scroll down further to the other account we've already logged in with. This is the local admin on this machine. And then just collect the hash value of that as well. And go back to Notepad and just paste it in. Now, if you observe these two hashes, you easily see these are perfectly identical with each other's. This is simply because if we're using the same password for different accounts, the hash value will always be the same. This is how Windows manages single sign-on. This is why we can use the password across multiple systems. It's stored encrypted in memory, the way we see it here with anti-hash encryption. This is a one-way encryption method, as we use hashes for that. But the same password will render the same result, the same anti-hash. So if we can observe multiple accounts running with the same anti-hash value, then we easily figure out or know that these accounts are sharing the same password, which simply means if I know the password for one of the accounts, then it's the same for the other one. So I can just go ahead and use that clear text password I know about just right away.
You can easily.
Yeah. The other very interesting scenario or situation we have here is that if I get that information, I can reuse that information, pass it along with something we call pass the hash. We'll be going through that as well. So we have
in the next session.
Yeah, we have tools that will allow us for doing that type of activities. So this is part of all the juicy information that we can find in memory. As you can see here, it's all about either running this directly on the target system, or we can run this on a mini dump file. We copy, extract from that target system and run on our systems.
All right, this is great information, and I used to get this question a lot when I go to the field.
Yeah.
I got a laptop, I hibernate it. What can you do with a
What can we do?
hibernated file? I know it's a big danger, and for people like us, we are aware of this.
Yeah.
So we showcase what is in the memory. Knowing hibernation is also keeping some space in the hard drive itself as well.
Yeah.
I believe you, as the wolf, can smell many secret information there, right? Can you please show our valuable attendees how they can see what is in there and what can be found?
Information from there. Well, a hibernation file is simply a copy of your memory at the time you instructed the computer to hibernate. Because we're copying the content of memory to a file on the file system, and we're instructing the CPU or the operating system, you should go into hibernation mode, which means you simply shut down, clear the memory, although we recorded all the content of the memory to that file.
Which is kept in the hard drive.
Yeah, next time we start up, we know that we did a hibernation in the previous cycle, so we will be starting up the basics of just loading the kernel, and then we'll go ahead and load the memory content from the hibernation file. So that's what we're going to do. And because of that, we know now the hibernation file does include all different aspects, all different pieces of information that was found in memory just before hibernation occurred. So if we start looking at that with the proper tool, we will sure find some very interesting pieces in there. Now, most of the times we need to retouch the hibernation file, reconvert it a little bit, so we get it in the raw format. Hibernation files could be not really encrypted, rather compressed, just to save some space. So we need to just work with them and then convert them back to the raw version of it. I already did that on hibernation file. Yeah, just to save time. This is a time-consuming activity. So I do have a hibernation file. Hyperfile.sys is this classic name for a hibernation file. I already converted that last night to converted.raw. And then you could work with that file. You can actually start scanning for strings, like text information and that. You will soon see a lot of information already by doing the strings operations on it. But let's use another utility. Use a utility called Volatility. This is a memory analysis tool. Available for free. This is a...
can download it,
yeah, just download it. Just search for it and just download it. And we use it together with those memory dumps. Now we will be doing that with the hibernation file and give it an operation and then tell it to use that file. So let's see, what should we look at?
I leave it up to your imagination. So what will be, as a hacker, your first target to look at?
Well, maybe dump hashes or look at information, let's see, image info.
Images, right?
Yeah. No, image info is about what is this memory dump, the memory image we have in our hand, what does it represent? So we can look at that. Regardless if it is a hibernation file or regular memory dump, I do have a couple of other memory dumps. There is a domain controller memory dump and then PC that's considered to be infected. So we can always look at any of these and say, hey, what's hiding inside these files? So volatility will work its way out. Let's see, yeah, and we of course need to specify a file name.
That, yes, please.
With the F switch. So it will start digging into those files and start trying to figure out what kind of operating system we're looking at. Is this Windows? Is this Windows Server, Windows Client? Just to tell the tool what are the suitable plugins to use when start looking in that one. So we always try to figure out where is that coming from. Now, guys working with virtual environments, it's very important to understand once you take a snapshot of a virtual machine, the memory associated with that virtual machine at that time will be kept as part of that snapshot as well. So you can convert that memory, that snapshot, back to a regular memory dump as well using similar tools. The Moonsouls toolkit is very useful there. So you can convert a snapshot memory image back to a raw memory dump and then work with it using Volatility. This one tells me now, if I look at the output, it says this is either Windows 2008 R2, it might be Windows 7, SP0, x64, it's an x64,
Suggested.
2008 R2 or Windows 7, with or without Service Pack 1. So then we can start working on it from there. Let's just do a simple net scan on that one.
So if you can please quickly tell what NetScan does.
Yeah, and then we need to tell the profile. Let me just complete that one.
No problem.
Of course, otherwise it doesn't know what to do with it. There we go. And then the profile is, otherwise the default profile is Windows XP, which doesn't really map to this guy. So we use that one. So the NetScan will basically look at network connection information that could be found in this file. Sorry. Oh, yeah.
Yes.
That's typically...
While you fix that, for the people they gonna download the tools, you can also find lots of online information there. Mm-hmm. I think you have also some stuff in your blog as well.
Yeah, that's right.
Which will give you at the end of the course highlighted with the PowerPoints as well.
Yeah.
Yes, Hasain?
So apparently we're looking at a domain controller. So if we switch back to this, it's still outputting that information. And this is, if you do a netstat on a domain controller, you'll see very similar output to this one we're seeing here. These are established connections, ongoing connections the domain controller does have with its surrounding. So this is just like if you're working interactively on the domain controller itself, but we're not doing that really.
Even though we have just a Hibernate image,
we're
so
looking,
it's not active PC. That's
right. We're looking at the domain controller's memory dump, and then we can extract this kind of information from it. It's very, very interesting way of looking at things. So let's do another CMD scan. CMD scan is another plugin, and let me do infected. Look at the PC memory dump, the infected.mem, and then let's see how much information we could get from that one. So the command scan option will give us all command lines found in memory. So this is basically a record of the command line history.
So I can see that he's using macros notice 2,
yeah.
psexec to,
You see the command process of the conhost, which is the console process in the Windows, and somebody has been playing around with psexec. And then they've been doing gsync dump. Gsync dump is one of the tools we published for some years ago. It's an open source to show the ability to extract hashes live from memory before the Mimikatz stuff. And then so they're basically dumping hashes from memory into that dump.txt file and checking their IP config, and then they are doing a net use with some admin credentials. Part of the things we dump, it could be clear text passwords. So apparently they got hold of that one, and they're doing admin SVC. This is probably a service account with the corresponding password to it. And then after that, they are doing a dump on the domain controller using psexec, which perfectly lays out what's happening. This is exactly the type of information we would like to see when we try to analyze memory dumps and images of memory in our system, regardless if this is a hibernation file or just a snapshot in time.
It's just
VM.
The same concept.
Yeah, the same concept will apply.
Which I want you to remember this demo, please. Later, I'm going to cover a few stuff, and I'm going to show you in the next module. Instead of redoing the same demo, I'm going to refer to this demo, but the outcome will be the same. Okay, Hasain, perfect. Yeah. You were talking about domain controllers. Domain controllers is the backbone of everything, right?
Yeah.
So let's imagine we have a fully hardened domain controller. Whatever you want, defense in depth, disconnected from the internet,
Yeah.
no direct connection, highly monitored, fully patched. What can the wolf
Yeah.
do to analyze this?
How
PC?
can we breach that?
Okay, that's the other question.
Yeah, how can we breach?
Again, why I'm asking this, Hasain? He is our ethical hacker for today, and we will demonstrate it to you, so you can just don't rely on, hey, I got the most secure server.
Yeah.
He is a beautiful proof that if you don't listen to us carefully, you really don't have the most secure server. Hasain?
Yeah. So if we look at the output from the previous command I just ran, this lays out pretty much the type of activity an attacker will carry out just to get hold of the domain controller or control the domain controller, and by that controlling the entire domain. So they were digging for local information on that client. Now we were looking at the infected.mem file. Okay, that's the client machine that was recorded or memory dumped. And on that client, somebody looked at the artifacts or credential caches available in memory. They were running gsec dump rather than running Mimikatz. Just another example of a tool that they can dump things with. And then they did the connection to the domain controller. Now this IP address is what we know about is the domain controller in this case. So by mounting the $C drive or share, then you know you're a domain admin. If that's on the domain controller, then you're a local admin. On the DC, then that's equal to domain admin privilege level. And then after that, they were executing bsexec directly on the domain controller. So in this case, this is just reusing the password as is because we could extract the password in clear text. So there are no vulnerabilities on that domain controller. That domain
fully patched.
Yeah, it's fully patched. It probably will never get hold of it in any other way. But because we had some kind of a service running locally on this machine with a privileged admin account, or somebody was logged in on that machine with a privileged admin account, same thing we showed just on this client. The domain admin logged in on this one, and then there are credentials left behind on that machine. Then those credentials will be possible to use by an attacker to get hold of other parts, other pieces of our ecosystem, like the domain controller or maybe some important servers and so on. And then jump from one system to another system by reusing that kind of information. Now, I already showed you the netstat stuff, and just to repeat that for the infected, if you do the net scan with the infected, the client, at the time of recording this memory dump, we know that there has been a live connection going between the client and the destination server, the domain controller, and we could easily spot that one in this operation. These are the IP addresses involved. So this is this type of artifacts we're looking for in those memory dumps. Has there been ongoing any TCP-based connections established between the systems? Can we see other type of artifacts residing in those memory dumps and so on? Can we tie it together? Well, we see the command history, we see that there was a connection, and then we can figure out, hey, somebody was reusing a password that happened to be a domain admin or gave them domain admin privileges on the domain controller. Of course, you need to output all of this to files to be able to a little bit easier analyze what the type of results we're getting. So we're just giving you a snapshot about what's available in here, what kind of information we could get hold of in here. The Volatility tool by itself can do a whole lot of things, including doing memory dumps, doing memory scans, and so on. So if we look at my screen again, these are some of the commands you can do. You can list files, you can list processes, DLLs, you can do memory maps, you can actually specifically dump the LSA process. You can dump hashes by this tool as well, and dump LSA secrets, do file scannings, and so forth. LSA dump and hash dump were very interesting. Hive dumps for registry dumps. You can dump certain registry keys by printing the keys and so on. You can get hold of clipboard info. You can get hold of screenshots and so on. It's a very, very extensive tool or toolkit for those interested in memory forensics. And you can add your own plugins to that as well if you would like to extend the functionality of the Volatility toolkit. So just a snapshot of what kind of activities, what kind of information we could get hold of. Just to show you the other parts, maybe PS list. This is the process list will be displayed. So this is just like looking at the task manager locally in that system, and you will see what's going on. Well, search indexer dot something. If there are any exe files, processes running that looks suspicious, we can start looking at them, dig deeper by giving their memory offset addresses, and then start, maybe we are interested in getting the binary image of that process to analyze it using some other tools, then it's possible. Because if it is running, then the binary itself is loaded in the memory. So we do have access to that as well.
Cool. Is there anything else that would you like to highlight in this attack?
It's up to your imagination what an attacker could be able to get hold of. If it is in memory, then it is certainly possible to get hold of it. It could be more or less obfuscated, could be more or less encrypted. Actually, all the LSA secrets we get hold of are encrypted in memory, but the decryption key is in memory as well. So if you're able to look for the decryption key and extract it, then you will be able to extract that encrypted piece of data as well.
Okay, this brings us to the summary. If you remember, we talked about memory, types of memories, and after the demos, I believe you know why it's important to maintain what is in the memory, at least to know what is in the memory. Yeah. Why? Because you could see this could be this infected file, a targeted phishing attack, where you fool a victim, which can lead an attack up to owning the domain controller.
Yeah.
That's why it's really important. Again, I keep referring back to the previous virtual academic course that we recorded, because I mentioned the mitigations there, like using or creating a service account to separate it with the domain account, or to use the least admin privileges. Again, I don't want to repeat sessions. Please, please, please go ahead and watch the previous recordings. And can you quickly tell your blog so people can go to your blog as well?
Oh, it's secadmins.com, secadmins.com.
Which you have lots of information there as well. And
adding to that summary you just did, Erdal, it is very important and very crucial. If we suspect some kind of illegal, unauthorized activity on our system, try to get those memory dumps done. Try to create a snapshot if the system is virtual. If it is not, try to just hibernate the system if it is possible, and then you will keep it sustained in that state. So we'll get hold of that hibernation file and can work with it. So if you see something going on the machine and you don't have any means of live memory dump on it, hibernation is a very nice piece of work you can do. So do the power config -h on and then hibernate the system right on. You will get a very nice memory dump to work with.
And this is also a good reason why you should lock your computer when you walk away from your desk, because can you imagine? I leave my computer on here, Hasain quickly puts a remove media, dumps these files into the USB stick. When I'm back, forget about sending funny emails to friends, but when I'm back, he will get access to everything and anything. So this brings us to the conclusion of this module, module 2. I'm looking forward to, actually we are looking forward to see you in our next module. Thanks for watching.
Thank you.